Hello everybody, today I want to talk about the process of neurulation and also vasiculation. I'm going to talk about the changes of the ectoderm in embryology in order to become and make the neural tube, and also after the neural tube in order to become the spinal cord, and also in order to form the cerebral hemisphere, diencephalon, midbrain, medulla oblongata, and these changes and how it happens, the neurulation, and after that the vasiculation or vasiculation. So in here, as you see, we have the ectoderm, mesoderm, and also endoderm. These are the processes which has happened before, and right now we are on the day 15 till 17. We want to see what happens from the day 15 and also 17 till the day, for example, 26, and a little after that. So we are talking about briefly a short period of time, not from the first day, but we start from the day 15. And in the day 15, what happens? The ectoderm has been formed before, and mesoderm also, endoderm also, and in here we have the notochord, which is part of the mesoderm. So notochord starts to release some growth factors, and these growth factors has receptors on the ectoderm. So what happens? These growth factors makes the ectoderm to has proliferation. It means that the cells are going to be more and have divisions and proliferate. So because of ectodermal proliferation, we have the neural plate, and neural plate is part of my ectoderm, and here the notochord and also the mesoderm, and notochord is part of the mesoderm. And what happens? So in the day 15 till 17, the notochord starts to release growth factors and proliferation starts. At the day 17, the neural plate is formed, and the cells at the center of neural plate will come down a little and want to make a groove like this. So the center of the neural plate will come down, and the folds are made, and these folds are called neural folds, and this groove is called neural groove. And at the tip of these folds, we have the neural crest. So it means that these cells at the center will come down, and here we are going to have a groove, but after that this groove is going to be closed, and then we have neural tube instead of neural groove. But at the day 17 we have a neural plate, and at the day 18 the neural groove. This is the neural groove, or that after this is going to become neural tube, and in here we have the neural crest. At the tip of this groove, at the tip of this neural fold, we have the neural crest, that later the neural crest is going to be separated also. And neural crest, in the next video I'm going to talk about it more, but will become several parts in peripheral nervous system. For example, it's going to make our ganglions, the sensory ganglions in the peripheral nervous system, and also it's going to make the chromaffin cells in the adrenal medulla. Or for example, it's going to make the neural crest only. It's going to differentiate into the structures of the head and also the neck, and some nervous systems which will feed the pharyngeal arcs, such as trigeminal cranial nerve, cranial nerve number 5, trigeminal nerve, or facial nerve, cranial nerve number 7, or number 9 and 10 together, which feed the pharyngeal arcs later. So it's going to differentiate into many parts, which I will explain it separately in details. But right now I'm going to tell you that at the day 18, the neural crest, which is part of this ectoderm and wants to be separated, is formed. And it is at the tip of neural fold, and this is neural fold. So this is neural groove, and this is my ectoderm, and here is my mesoderm, and in here notochord and endoderm. Look, in this video I'm not going to talk about mesoderm or endoderm, but while these changes are happening in ectoderm, there are some other changes in the mesoderm and also endoderm, which in the next videos I'm going to talk about it more. But right now I'm going to focus on the neural tube. I'm going to focus on the changes of this neural tube, but not any part of the ectoderm anymore, but not the notochord, even not any part. Just I'm going to focus on this neural tube and its changes and how it's going to make our CNS, central nervous system parts. Okay, So at the day 19 till 20, I have my ectoderm in here, and this is my ectoderm. I have my neural tube, which has been separated completely. This is my neural tube, and it's going to be made. And finally, this neural tube is going to be closed and be separated from my ectoderm. So this is my neural tube, which has come down, being separated at the day 19 till 20. And here are neural crests at the tip they will become separately. I have made them red, but they are part of the ectoderm, not mesoderm. For example, mesoderm is here red, here red, here red, here red, and endoderm is green. But I want you to keep in mind that these neural crests are part of my ectoderm. I just have been separated them by the color red, so it will be clear for you. And here is my notochord endoderm. So this happens at the day 19 till 20. And this process, which I explained right now, is called neurulation. Neurulation. It is called this process, which I'm going to have my neural plate, neural tube, is called neurulation. And in here, there is another view. This was looking from this point of view, and this is another kind of view, which here I have my neural tube. I wanted to tell you at the day 19 and 20, I have my neural tube, and at the day 21, my neural tube is completely separated and completely made, okay? But this tube has a pore, opening pore, closing pore, and here there is a pore. It means at the tip of it and at the end of it, it is open, and that is because it is called pore. So what happens? This anterior neural pore and posterior neural pore. So this is the cranial part, this is the caudal part. The cranial part has the anterior neural pore, and the caudal part has the posterior neural pore. These pores must be closed. Why? Because at the tip of my CNS, which is in here, there mustn't be any opening in my CNS, in my cerebral hemisphere, for example, or in my spinal cord. There is no pore, because this CNS fluid, is just circulating in a closed system, not in an opening system. So these pores must be closed. What we need, just keep in mind that for closing these pores, we need folate or folic acid, and the amount of it is 3 till 5 milligram per day. So if the person, the mother, must eat folic acid or folate in order to close these pores. If not, the embryo will not survive or will have problems. So we need folic acid to close these pores. And the anterior neural pore will be closed at the day 24, and the posterior neural pore, the posterior neural pore, will be closed at the day 26. It means at the day 24 and 26, completely my neural tube is made, the pores are closed, and I'm now going to talk about the process vasiculation from now on. I mean that the process neurulation has been finished. It's finished. Everything was made and the pores are closed. We are on the day 26, and vasiculation is going to be started. So here is my caudal, the cranial part, the caudal part, the first, the tip, and also the end, the caudal part. What happens? First of all, there is a primary vesicle in here, which happens, the primary vesicle. So this is the primary vesicle. This cranial part is going to change, the caudal part is going to change, the caudal part is going to make the spinal cord, this part till the end, and the upper part, the superior part of the cranial part, or the superior part of this tube, is going to make my cerebral hemisphere and some other parts, which is in central nervous system, but in the head and also the neck. So what happens? In the head, but not the neck. So what happens? The cranial part is going to have the primary vasiculation, the first vasiculation or primary vasiculation. And it's going to have 3 vesicles. These are like vesicles, which are called the prosencephalon, the mesencephalon, and rhombencephalon. So they are called prosencephalon, mesencephalon, and rhombencephalon. Okay? So the prosencephalon, mesencephalon, and rhombencephalon. The prosencephalon is going to divide and make the secondary vesicle. But what are they called? The prosencephalon is making the telencephalon. This is the telencephalon, and diencephalon. What is diencephalon? Diencephalon consists of my thalamus, hypothalamus, subthalamus, epithalamus. Epithalamus is like my pineal gland, or the the thalamus has its own lateral geniculate body, medial geniculate body, and they are going to make a little part of the limbic system, because limbic system consists of a little part of hypothalamus and also its relation to the thalamus. So we are going to have the prosencephalon to be changed to telencephalon and also diencephalon. Mesencephalon still remains in this process, but rhombencephalon is going to be the metencephalon and also the future cerebellum. So it's going to make the metencephalon, the future cerebellum, and also myelencephalon or mielencephalon, which is going to become my medulla oblongata. So this is the secondary vesicle. So what happened? Another time, the cranial part is going to change to have some vesicles. 3 vesicles first: the prosencephalon, mesencephalon, and rhombencephalon. And prosencephalon is going to make the telencephalon and diencephalon, which telencephalon will become the cerebral hemisphere, and diencephalon is become, you know what is diencephalon? The thalamus, subthalamus, epithalamus or pineal gland, and which is consists of the pineal gland, of course, the epithalamus, and also hypothalamus and parts of limbic system. So in here, or the limbic system, or in here, the mesencephalon will not change, but mesencephalon later become the midbrain. And also the rhombencephalon will become the metencephalon, which metencephalon will become the pons, and also the cerebellum, which the parts of cerebellum is not going to be completed in here. Just we have metencephalon, later it becomes the pons, and also cerebellum, a little parts of cerebellum. And myelencephalon, which is part of the medulla oblongata, which is going to be medulla oblongata, and in here is going to become the spinal cord, which in the next video I'm going to talk about the spinal cord and its layers more than this video. But the telencephalon will become the cerebrum, cerebral hemisphere. The diencephalon will make the thalamus, medial lateral geniculate body, subthalamus, and also epithalamus, which pineal gland is part of the epithalamus. And here, of course, there is a limbic system, and also mesencephalon is become the midbrain, and metencephalon becomes the pons, and also the cerebellum, the hemispheres of the cerebellum, and in here we have the medulla oblongata, which is originated from mielencephalon, and in here we have the spinal cord. So in this video, I try to concentrate on neurulation, also vasiculation. And in the next video, I'm going to talk about and concentrate on the neural crest and its changes, which is going to be the PNS. It's going to make different parts of the head, neck, and also some cranial nerves, which will nourish the pharyngeal arcs. For example, cranial nerve number 5, 7, 9, and 10. Number 5, trigeminal nerve. Number 7, facial nerve. Number 9 and 10, the vagus nerve, and also glossopharyngeal nerve.